here today. If you don't know me, I think everyone knows me, but I'm Kathryn Dryden with ABGC. We have Rosie Godwin here, our R&D manager, joining us from our Rockley office, and also Jon Loraine from Carbonovia. I'll let Rosie do an introduction first, but thanks for joining us for our second webinar. Very short, succinct webinar. There'll be opportunity for questions at the end. We'll just let Jon run through his short presentation first to give you guys a bit of a introduction to what he's doing. And yep, I'll hand it over to Rosie.
All right, thank you, Kathryn. Just to set the scene a little bit, I got to know Jon and I thought it'd be interesting if he came and gave a talk. I thought maybe growers may be interested. It all came about after we finished doing the Banana Waste Sector Action Plan last year, which was a levy-funded project looking at banana waste along the supply chain, and it showed that there was a significant amount of banana waste, as you'd all know, that is formed at the shed, I guess, or dropped in the paddock, and it's aggregated there. And around the time when that project was finishing, a few recommendations were made to examine ways that could be found to value add with some of this waste. And then Jon came along to me with an idea, and he's from a company in the UK looking at ways of using different sorts of horticultural waste. And so he was interested in talking to some growers about how they use their waste. And so we thought it'd be an opportunity to do a short webinar on what he is doing. So we've invited Jon to talk about his work today. So over to you, Jon.
Thank you very much indeed. And hello, everyone. Just to check, we are recording this as well, I think, aren't we?
Yes.
Oh, yep. Yeah. Thank you, Jon, for letting us know. Yeah.
Rightio. Thanks, Kathryn. So thanks for giving me a chance to talk to you. I'm actually based in Brisbane in Queensland. Carbonovia originated in the UK, and it came out of research to look at taking kind of agricultural waste materials and turning them into high value proteins. So it's based on research that's been done in the UK over the past several years. So if we can just move down one slide. And what this is all about is we can take a wide range of agricultural waste materials, and through the process that has been developed, and it's essentially a biodigestion process, we can turn it into high protein rich cells. And this material is very like soy meal. So it's got a lot of the sort of amino acids and proteins and fats that soy meal has got in it. And these are very well-known ingredients in stock feeds. And they trade widely around the world. They're worth about $800 per ton. And we've tested this on a wide range of feeds, including like wheat straws, sisal waste in East Africa, and we've done test work on bananas. And when we talk about banana waste, it can be waste bananas, but also pseudostems and leaves and other material. It can all be quite efficiently converted into this high protein material. Actually, look at the picture there, the little container down in the bottom there is what this stuff looks like. It's a pink powder. And it's a very well-known sort of common ingredient in, as I said, in stock feeds, particularly for fish, chickens, and pigs. If I can take the next slide, thanks. And what this would look like in practice is, you know, we've done sort of studies on a plant that would take about 35,000 tons per annum of feed. Now it can run at various sizes. And you're basically taking the feed material. If it's bananas themselves, this is fairly straightforward process of basically mulching them, if you like, extracting the sugars, fermenting the sugars, drying. You're growing yeast here. So the objective of fermentation is not to make alcohol or to make carbon dioxide. It's to actually grow yeast cells. And we've got proprietary yeast cells that have already been developed over the last couple of years. And then you're basically extracting these yeast cells and making them into a dry powder. You can also take kind of non-sugar feeds like basic vegetable material and have an initial anaerobic digestion stage, which also can convert this stuff into fermentable material. At this sort of scale, 35,000 tons per annum, you're looking at a little plant that would be about the size of a tennis court. So it's quite small in scale, but it's it's quite a nice economic size. And I'll talk a little bit later about how we see these things being operated. So, we're really keen to come and talk to some of you growers, just get a better understanding of what happens on your operation, what sort of waste you produce, get a bit of an idea of layout and logistics, and we can talk a bit more about what this would look like. I should sort of remind at this stage, this is still really a research and development project, and we've got a bit of a timeline which I'll talk to in a minute. We're moving quite fast, but we're still kind of going through the development stages. Forget the next slide, thanks. So this product is a really good replacement for soy meal, and soy meal is the basic ingredient in most stock feeds, and stock feed manufacturers realize they've actually got a sustainability problem. So soy meal is a very unsustainable crop. It uses valuable arable land. It's a high water crop, and actually growth in soy meal around the world largely comes from knocking down rainforest in South America. So it's there's real sustainability challenges in using soy meal, and they also use fish meal, which is a very unsustainable feed. So they're pretty keen to see things like this that come from agriculture sources. The product we make is plus 40% protein, and with a mix of lipids and amino acids very similar to soy meal. So it's highly nutritious material. One of the really interesting things about using particularly banana feeds we've run this on, is it can be very high in carotenoids. And these are the things that make your egg yolks orange and your salmon fillets nice and pink. And carotenoids are a very expensive component of stock feeds, and it looks like these are actually naturally arising in what we do here. Every ton of fresh banana waste that we use saves a ton of CO2 emissions, and every time we build a 35,000 ton per annum plant, it saves 1,000 hectares of deforestation. So it's we really think it's got important environmental implications. But the good news is it also is quite economically viable. So if I can take the next slide. So we've just sort of done a bit of background work on an assumed size of 35,000 tons per annum of banana wastes. I'm not trying to match to anyone's operation here. This is just an example. It could be bigger, it could be smaller. That'll produce nearly 4,000 tons per annum of product. This product is worth about $800 a ton, 800 Australian dollars a ton, and it's a traded commodity. So the pricing is sort of global pricing. And the capital cost of a plant, is in the range of $4 to $5 million, and it can make nearly $2 million per annum margin. So it's quite a high margin piece of kit with a payback in the order of 2 years. Now, just to sort of stress where we're at, we're aiming to do sort of bench scale trials this year. We've done a bit of this in the UK, but want to get it transferred here, and then ideally move towards doing some commercial scale demonstration plants in about 12 months time if all went well. And we're not asking anyone at this point, we're asking at all for sort of capital or contributions to costs or anything. All I really want to do at this stage is just try and meet up with interested parties and get an understanding of your operation, and tell you a bit more about what we do, and then we'll start to do some bench scale tests on materials, and and get a better picture of what this would look like over the next year. And then the future sort of model could be that we own plants and pay for feed. It could be that growers own plants. It could be their joint ventures. It could be a third party builds these plants. The plants could be actually on a plantation, or they could be regional. And these are all future sort of things to think about. You know, one of the things we want to get an understanding of in the next while is just where waste arisings are, so we can work out what the logical place for potential processing plants is going to be. But I'm not asking for, you know, capital or actually any major work at this stage, just to really make some introductions and start to share a bit of information. If I look at the next slide, please. Just sort of timelines at the moment are, I would really like to get up and meet, you know, interesting parties in the next couple of months. So after this, I, you know, be kind of asking people to put their hands up if they're interested in talking further. We'd enter into a little agreement with you just so we can share information. We will be aiming to bring over the UK bench scale, like laboratory scale test work here in the next few months as soon as we can, and start to replicate small samples, and that'll give us some product. And then we'd hope to get a larger scale demo plant by the end of the year. And that's possibly, you know, up to 1,000 litre scale, which will start to produce hundreds of kilograms of product for testing. And at the same time, start to talk to stock feed manufacturers and get them testing the material. We really don't see too many problems with them finding it acceptable. There's a lot of interest already. And as I said earlier, you know, a potential commercial scale is around 35,000 tonnes per annum of waste. Could be bigger, could be smaller. It can be scaled up or down pretty easily. And, you know, if we're ambitious and optimistic, that could be, you know, getting into 2025, that we'd like to get to that stage. So that's the plan of attack. So I'm really keen on trying to meet up. It works very well on bananas, I should say. All the test work is it's a pretty robust process. It produces good product. The yields are good. The cost structure is good. You know, we're trying other feeds at the moment. We're doing work in Africa on sisal, but you know, bananas are particularly good feed. So really keen to try and get talking to a good group here and start to share some information. So that's where I'm at. I've got details below. If you're keen to sort of take it further, you know, as I said, I'd try and get up and around and meet people face to face in the next few weeks. And my contact details are there, but you can contact through Kathryn or Rosie as well, and we'll organise to have some chats.
Thank
So
you, Jon.
that was flying through that. There's quite a bit to think about there, but I think the idea is now, if you've got questions or want to discuss, really happy to have a bit of a chat. Thank you.
Please feel free to put in any questions or comments. Just make sure you remember to unmute yourself so we can hear you.
Hey, Kathryn, Matt here.
Hey, Matt.
How are you?
Good. Go ahead.
Hey, what's the timeline between once the fruit's harvested to when you need it processed? Is it critical, like the time, and how does it need to be whole, or is it chopped in pieces, or does that matter?
Matt, thanks. It doesn't need to be whole. In fact, it would get macerated as the first stage of what we're doing. I guess one of the things to sort of really look at site by site is just how you collect material. And so we need to talk together about how we'd handle it, how we'd handle this waste, and how and if it needs to be stored before processing.
Jon, would it be the sort of thing whereby if a grower, like considering that you're going to use it, say, for a fermenter, it wouldn't matter in that case because the yeasts are going to be growing on it if you even had to freeze it for a while, even though, you know, that might not be ideal. You could stabilise it by freezing it, couldn't you, and then chuck it in the fermenter? Is that an option? Yeah,
look, we've within Carbonovia, we've built anaerobic digesters before. And generally what you do is have a sort of a yard with bays in the yard and just have material piled in bays and handled by a bobcat. and then dropped into a feed hopper. So it's, you know, if it's like that, it's pretty simple. But I mean, you know, like, bananas are a sort of material that will obviously change quite quickly if they're left in a heap. So we just need to look, you know, that's exactly the sort of things we need to talk about, is the practicalities of handling it. Like dry vegetable material, or, you know, well, not dry, you know, leafy material or stalky material, you know, where it's going into anaerobic digesters, it just sits in a heap. And actually, if it starts to sort of decompose, that's actually helpful. It's starting the process off. Now, but I mean, I think there's going to be a whole bunch of particularities site by site about how we handle bananas at the front end.
I have a question in the chat from Sarah. Jon, can you talk to how the product is currently being sold and how it compares to other feed options, i.e. cost comparison, etc.?
Yes. Look, a stock feed manufacturer currently will be paying pretty much the world price for soy meal. So that's currently about 800 Australian dollars a tonne. And, you know, soy meal is a dry, powdery material, and it's handled in bulk. So, you know, it can be handled in bulker bags, or it could be handled in truckloads or even shiploads. And it could be transferred and, you know, rehandled just like any other sort of similar material. You know, so using, you know, like screw conveyors or, you know, buckets, whatever. This material at the end of the process will be a dry powder, and it'll be put into silos, I would expect. And then ex-site, it will go out in either bulker bags or in bulk shipments. So it will be kind of low moisture, but, you know, it's a drying stage at the end of this, so you'd have something that's probably, I don't know, below 10% moisture.
And Jon, would you be able to use, you said before, I saw in the diagram there was some aspects that could be used to produce biogas. So I presume you could have another section of the plant where you might be using another part, like, I don't know, peduncles or something, for driving a biogas to actually drive the drying of the plant.
That assumption there was that we weren't converting the non-sugary material into feed for fermentation, in which case you have a biodigestion which will produce methane. That's pretty straightforward if you want heat on site. Now, if there's a large amount of non-sugary material, then your biodigestion, you'll mainly produce acetic acid, and that goes straight into the fermentation. So you produce acetic acid. You certainly produce methane on, you know, at that point to some degree, and it's available then to, you know, generate electricity or make heat.
Yeah.
There's a lot of practical questions here about, you know, just how wastes are handled at each site, you know, and the layouts, which is what I'm really keen to sort of talk to individuals about. And, you know, I think there's a whole bunch of choices about how we might build and operate these plants as well. So, you know, all the way from having it run by a third party and the grower just earns, you know, a fee per ton of feed or a profit share, all the way through, you know, at the end of the day, they'll be pretty stable things when they're up and running, you know, to being things that someone runs on their own operation and just gets another good revenue stream going.
I guess an advantage, oh, sorry, go ahead, Matt, was it?
Yeah, I was just going to ask Jon. Jon, you talked about the moisture content of the finished product.
Yep.
If, like in our environment, obviously we've got a lot of moisture in the air. Is that that adds much cost or complexity to say compared to doing it somewhere where it's a lot drier?
It's a great question, Matt. So we've been looking at, you know, either some good technologies for solar drying, you know, and using, for example, heat pumps, all the way through to like forced drying using, you know, methane. So again, like it's still, we're really in the engineering stage at the moment, Matt, trying to work out what equipment actually does all the stages, and drying is an important one. And you're dead right. Obviously, you're in a humid sort of, but sunny and hot environment. So, you know, there's a bit of work to be done just on what suits each place.
I guess the main thing that you're looking for in the next year too is just those conversations and maybe those 10 kilogram samples to test the products, aren't you?
Yeah. So our work right now, we've kind of, you know, we've done the whole process at bench scale in a laboratory to produce product. So we're like, all the chemistry works fine. Like our really immediate next stage, and actually kind of speaking back to Matt's question there, is actually identifying equipment sizes and specifications. And in some cases, like drying, actually, what's the technology? You were looking at what filters are required, you know, all these bits and pieces. Pretty much all the equipment we need to do this is conventional. It's already been used in the agriculture industry or the food industry, but we're just starting to sort of zoom in a bit more on sizes, suppliers, costs, all of that sort of work's going on at the moment.
And I see that you're working with QUT, so is that a joint project that you've got with them? So
QUT is potentially a good collaborator. So they've got laboratory facilities, both bench scale and at a pilot scale in Mackay, and they've done a lot of work on biodigestion. So they've actually got a lot of the equipment and a lot of the know-how. So we have an MOU with them, and they're a really good candidate to be doing the bench scale work that we're going to bring over here and possibly be the location for a pilot plant. Now, we're also talking to Molly Chapman at the Fight Food Waste CRC. That was introduced by you, Rosie, thank you. And she's really interested in what we're doing as part of the Fight Food Waste research work. And, you know, there may be some potential for some of this work to be done under, you know, a project within that research piece of work. Yes, so there's, you know, there's quite a good bit of knowledge already in Queensland on, you know, on biodigestion particularly, and fermentation. You know, making ethanol is one of the things that's been from crop materials. Have been a lot of work done over the last 20 years.
Is that for biofuels or?
For biofuels, yes. You see, that's actually like, you know, what we're seeing around the world is that biodigestion to make methane, to make electricity is actually, the economics aren't really strong. And it's worked a lot in Europe where there are big subsidies, but the subsidies are running out. Because attention's going to other things now, really, rather than making biofuels. And again, in Queensland, I feel the research enthusiasm is sort of moving a bit away from making ethanol. Mm. But we make a much higher value product this way. I mean, this is much higher value product than making methanol or ethanol or methane.
Mm.
Okay, well, we've got 5 minutes remaining, so I guess I'll just open to the floor for a final question or two. Is there any other growers with pressing questions? Now's the time to ask.
And what I'd really like is, you know, is whoever's interested, please make yourself known to us, and either directly to me or to the association. And I would like really much to come up sort of and visit your operation the next few weeks.
Okay. Well, thank you, Jon, very much for your time, and thanks to you guys who joined us today. I hope you found it valuable, and I hope, Jon, you can get enough interest to make it worthwhile coming up. It'd be great to see you up here.
Yeah, great. Kathryn and Rosie, thanks for helping to put this together. You're better at the technology than I am, but we got there.
Okay. Just to add, if anyone has any questions they want to ask me, they can also give me a ring, and I can help put you in touch with Jon. Yeah.
Great, thanks a lot.
Okay, thanks. Have a great afternoon, everyone.